Welcome to this explainer. Today we're cracking open one of the most fundamental, universally repeated rules of aquarium keeping. If you've ever set up a tank, you absolutely know there's a golden rule every beginner learns right out of the gate. But, what's really fascinating is how rarely we actually stop to look at the hard science behind it. Don't put tap water straight into the tank. Rest it for a day. You've probably heard this, right? Maybe you've even said it yourself. It's basically treated like gospel in the hobby. But you actually know the invisible chemical war that takes place in your aquarium if you just ignore this advice. We kind of just accept it as fact. But the truth is, throwing raw tap water into a thriving aquatic ecosystem sets off a chain reaction that can be literally catastrophic. So we really need to ask some critical questions here. Are we supposed to rest it for 24 hours? 48 hours? Do we actually need to use chemical conditioners? What really works, and why? In this explainer, we're going to put on our detective hats and uncover the hidden variables of water chemistry that separate a beautiful, thriving tank from a total disaster. Let's start with the source itself.
Think about the water flowing out of your tap for a second. It's engineered for one primary species, us, humans. We want our drinking water to be completely free of microorganisms, right? We use it for cooking, drinking, washing, so municipal systems run it through some pretty rigorous disinfection protocols. And hey, that's perfectly fine for us. But an aquarium is the exact opposite. It's a living, breathing biological engine. The very thing that makes tap water safe for us makes it incredibly hostile to aquatic life.
The primary weapon used in all that municipal disinfection is chlorine. While it's absolutely fantastic for keeping our plumbing sterile, chlorine is a complete nightmare for fish. Fish live directly in this environment, and their gills are in constant contact with the water. When exposed to raw tap water, high levels of chlorine literally burn and damage their gills. This triggers an immediate massive spike in stress, which alone can be completely lethal. But, and this is crucial, the danger doesn't stop with just the fish. There is a whole invisible ecosystem at stake here, the nitrogen cycle. When you look at your aquarium, you see the fish, the plants, the rocks, but the true heroes, they're totally invisible. Millions of beneficial bacteria are living in your filter, your substrate, and on your rocks. They're the ones breaking down decaying fish food, dead leaves, and organic waste into ammonia, and then magically converting that highly toxic ammonia into much less harmful substances. Remember, chlorine's explicit job is to kill microorganisms, so adding untreated tap water actively destroys this delicate biological filter, completely crashing your tank's ecosystem. So here's the good news. The traditional habit of resting water actually works precisely because of the chemical nature of basic chlorine. Chlorine is a volatile gas. When you leave tap water out, especially in a wide-mouth container that gives it maximum surface area, that volatile chlorine naturally off-gases. It just evaporates right into the air. A lot of hobbyists even speed this up by dropping an air stone into the bucket to increase gas exchange. So that old wait-a-day rule, it actually has a very solid basis in chemistry.
Okay, but hold on, because here is a massive plot twist. This is where so many aquarists get it totally wrong. The biggest mistake hobbyists make is assuming all tap water everywhere is treated exactly the same way with that easily evaporating chlorine. Well, it's not. Many municipalities have actually switched to treating their water with something called chloramine, which is a chemical bond of chlorine and ammonia. And here's why that is a total game changer. Chloramine is incredibly stable. It was literally engineered not to evaporate easily in the pipes. If your city uses chloramine, resting the water in a bucket for 24 or even 48 hours is simply not going to cut it. The chemical stays trapped in the water, remaining highly toxic to your fish. In these situations, using a specific water conditioner, one that breaks that chloramine bond and neutralizes both the chlorine and the ammonia, is absolutely mandatory. No way around it. Now, even if you're lucky enough to just have standard chlorine in your local water, there's still no universal 24-hour rule. That's because the physics of evaporation rely on a bunch of shifting variables. Think about it. How warm is the water? What's the total volume of the container you're using? Is it a narrow jug or a wide-open bucket? Is there surface agitation from an air stone? All of these physical variables dictate exactly how fast that gas actually leaves the water. You really have to know your own specific setup. So, this brings us to a really fascinating secondary layer. Is removing chlorine the absolute only reason we rest aquarium water? Well, if you thought the answer was yes, you're missing half the equation. We have to step away from just looking at the chemicals for a minute and start looking at the physical properties of the water itself. A massive and largely hidden danger of direct tap water usage is thermal shock. Just think about the winter months. The water, coming straight out of your pipes, might be sitting anywhere from 15 to 20 degrees Celsius. Meanwhile, your beautiful tropical aquarium is happily heated to a balmy 25 or 26 degrees. Pouring that freezing cold tap water directly into a warm tank creates a violent, localized temperature drop.
Resting your water solves this physical problem completely effortlessly. Just by letting the replacement water sit in your home for a day, it naturally equalizes with your room temperature. This makes routine 20 to 40% water changes vastly safer for your tropical fish, totally eliminating the risk of sudden, fatal thermal shock. It's such a simple step, but it literally saves lives.
Okay, so resting removes chlorine and equalizes temperature. Sounds like a magic bullet, right? But wait, does time alone really cure all tap water issues? Let's take a hard turn into some myth-busting because there is a really dangerous misconception floating around the hobby regarding what resting water can actually achieve. We really need to debunk a massive myth surrounding TDS, or total dissolved solids. This is basically the measurement of all the dissolved minerals and salts in your water. Essentially, it's how hard your water is. Lots of people falsely believe that just letting water sit in a bucket for 2 days magically lowers the TDS and softens the water, making it perfect for their aquarium.
Actually, scratch that. The harsh reality is that hard tap water stays hard. Dissolved minerals like calcium and magnesium do not just vanish into thin air just because the water sat in a room. If you're keeping sensitive fish species that require very soft water, resting your tap water achieves absolutely nothing for them on a mineral level. You still absolutely need specialized solutions like reverse osmosis systems or specific purifying filters to actually alter the water's fundamental hardness.
Yet, despite everything we've just covered, if you spend any time on aquarium forums, you will inevitably run into this incredibly common claim. Well, I put tap water straight in, right from the hose, and nothing happened to my fish. Sounds pretty convincing, doesn't it? But this is a textbook example of survivor's bias, and it completely ignores the actual mathematics of water chemistry.
To understand why someone might get away with it, we just need to look at the math of volume and dilution. Say you change out 5 liters of water in a massive 100-liter tank. You're only introducing 5% raw tap water. That toxic chlorine is instantly diluted by the massive volume of safe water, and the fish can likely tolerate the minor spike. But if you do a 70-liter change on that exact same tank, meaning you're adding 70% raw tap water, there is almost zero dilution to protect them. The result? Lethal shock and a completely crashed biological filter.
So just getting away with using direct tap water once during a tiny top-off does not mean your tap water is inherently safe. Safety relies entirely on the dilution volume, the specific chemical makeup of your local municipality's water, and the unique sensitivity of the fish you keep. The safest, most logical long-term path for any hobbyist is to just remove the guesswork entirely. Always properly condition or rest your water.
And speaking of sensitivity, when you're dealing with fry, baby fish, the margin for error completely shrinks to zero. Fry simply cannot handle sweeping chemical or thermal changes. So instead of doing a large, comprehensive water change, you must heavily control the process. In a 50-liter fry tank, for example, strictly swap out only 5 to 10 liters at a time instead of 20. Smaller, highly controlled changes are absolutely the only way to ensure the next generation thrives.
So we've broken down the chemistry, the thermodynamics, and the myths of dilution. Now it's time to investigate your own routine. Do you actually know if your local water uses chlorine or chloramine? Understanding your specific local water supply is the absolute ultimate key to a thriving tank. So right before your next water change, ask yourself, are you truly refreshing your aquatic ecosystem, or are you accidentally declaring a chemical war? Because as we've seen today, what you can't see is exactly what dictates life or death in your tank.